Sections 7.3 and 7.4, Solving Simple Equations. First, we're going to talk about solving algebraic equations. The letters in an algebraic equation are called variables. Each value of a variable that makes an equation true is called a solution of the equation. Sometimes more than one value of the variable may make the equation true. Solve x plus 3 equals 7. This is very simple because you know that adding 4 to 3 equals 7. So the solution to this problem is x equals 4. For the equation 2x minus 9 equals 18 minus 7x, the solution is 3 because when you substitute 3 for the x in the equation, both sides of the equal sign are the same. 2 times 3 minus 9 equals 18 minus 7 times 3. 6 minus 9 equals 18 minus 21. Negative 3 equals negative 3. So both sides of the equation are the same. Equations with the exact same solution are called equivalent equations. 2x plus 7 equals 13 and 3x equals 9 are equivalent equations because when you substitute 3 for the x's in both equations, it solves both equations. 2 times 3 plus 7 equals 13, and 3 times 3 equals 9. 9 equals 9. Adding and subtracting to solve equations. Guessing is not a very dependable way to solve algebraic equation. We need some rules to help us. An equation must be balanced on both sides of the equal sign. In order to keep that balance, whatever you do to one side of the equation, you must do to the other side. Very important, whatever you do to one side of the equation, you must do to the other side to keep the equation balanced. If you add a number or variable to one side, you must add it to the other, and the same is true with subtraction. If you subtract something from one side, you must subtract it from the other. The whole purpose of performing these operations on an algebraic equation is so you can isolate the variable on one side of the equation. Get it by itself on one side to solve for the equation. An example, x minus 4 equals 2. We want to solve for x, so we need to get x on one side of the equal sign by itself. You know that if you subtract a number from itself, the sum will be 0. 2 minus 2 equals 0. 3 minus 3 equals 0. If you add the positive of a number to its negative, that sum will also equal 0. This is how we move a number from one side of the equals to the other. X minus 4 equals 2, so we're going to add 4 to both sides to move the 4 from the left side to the right side. And since the 4 is negative, we need to add a positive 4 to make it 0. So now, x minus 4 plus 4 equals 2 plus 4. X minus 0 equals 6, so x equals 6. If you substitute 6 for x in the equation, you can check your answer and you'll get a true statement. 6 minus 4 equals 2. Now stop the video and try to solve this one on your own. 9 plus x equals 14. So solving, subtract 9 from both sides and remember to keep the equation balanced. 9 plus x minus x equals 14 minus 9, so x equals 5. This method of solving algebraic equations also works with decimal numbers and fractions as well as whole numbers. It's the same process. For example, 8.4 equals 3.1 plus x. We want the x by itself on one side, so we're going to subtract 3.1 from both sides. 8.4 minus 3.1 equals 3.1 plus x minus 3.1, and we get 5.3 equals x. The solution is x equals 5.3. A fraction example, 1/4 equals x minus 1/2. We can add 1/2 to both sides to move the half from the right side to the left side. Since 1/2 is negative, we add to make the sum 0. 1/4 plus 1/2 equals x minus 1/2 plus 1/2. We have to make the denominators the same in order to add 1/4 plus 1/2, and when we do all that and solve, we get x equals 3/4. Now, multiplying and dividing to solve algebraic equations. Previously, we added or subtracted to solve because the numbers were added to or subtracted from the variable. In some equations, the variable may be multiplied or divided by a number. In these cases, you will do the opposite operation to the one being performed on the number. For example, in 2x, the variable x is multiplied by 2. To isolate the x, you will divide by the number 2. So, 2x divided by 2, the 2's cancel in the numerator and the denominator, and you're left with just the x. For x over 3, the variable x is divided by 3, so to isolate it, you'll multiply by 3. X over 3 times 3 over 1 equals x. The 3 in the numerator and the denominator cancel, and you're left with x, just x by itself. Here's an example. Solve 27 equals negative 3x for x. You need to get the x by itself on one side, and you want it to be positive. Remember, when you divide a negative by a negative, it becomes positive, and you want your x to be positive when you solve for it. So you divide both sides by negative 3 in order to move the negative from the right side to the left side. Dividing by negative 3 makes the x positive. So 27 divided by negative 3 equals negative 3x over negative 3. The 3's cancel, the negatives cancel, and what you're left with on the left side is a negative 9. Negative 9 equals x. Here's an example. Solve negative x over 4 equals 5. Turn off the video, try to solve it, and we'll go over the answer on the next slide. To isolate the x on the left side of the equal sign, you will need to multiply by negative 4. When the negative sign is in front of a fraction, it can be assigned to either the numerator or the denominator, but not both. We can choose what we want to assign it to. So for this problem, we're going to assign the negative sign to the 4 in the numerator. This will cancel both the 4 and the negative sign and leave you with a positive x on the left. So negative x over 4 times negative 4 over 1. We're going to cancel a negative 4 in a numerator and a negative 4 in a denominator, and that will leave us with just the x on the left. 5 times negative 4 is negative 20, so that leaves us with the solution, x equals negative 20. Here's an application problem. The capacity C of a conveyor belt in metric tons per hour is given by the formula C equals 3.6 SDA, where S is belt speed in meters per second, D is density of the load material in kilograms per cubic meter, and A is the cross-sectional area of the load in square meters. Suppose that a load material has a density of 750 kilograms per cubic meter and a cross-sectional area of 0.083 square meters. What belt speed is needed to move 1,000 metric tons per hour? Try it on your own, turn off the video, and we'll go over the answer on the next slide. The first thing we want to do is substitute the information that we're given for C, D, and A into the formula. The formula is C equals 3.6 SDA, so substituting 1,000 for C, 3.6 S, which is the unknown that we're trying to find, substitute 750 for D and 0.083 for A. Now we're going to simplify by multiplying. 1,000 equals 224.1 S. To solve the equation for S, we have to divide the right and left sides by 224.1 to isolate the S. 1,000 divided by 224.1 equals 224.1 S divided by 224.1. We can cancel the 224.1 in the top and bottom of the fraction on the right side. On the left side, we divide 1,000 divided by 224.1, and we come up with S equals 4.462 meters per second, rounded to 4.5 meters per second. Solving two-operation equations. Solving algebraic equations often involves both kinds of operations, addition, subtraction, and multiplication, division. Solve for y. 23 equals 9 minus y over 3. The variable can be any number, and in this case, we've decided to use y for the variable instead of x. So we need to get the y by itself on one side of the equation. The first thing we're going to do is move the 9 from the right to the left by subtracting 9 from both sides. 23 minus 9 equals 9 minus y over 3 minus 9, and we get 14 equals negative y over 3. Remember, we want to isolate the y by itself. So the next thing we need to do is multiply both sides by negative 3 so that all we are left with on the right is a positive y. And remember, we can assign the negative sign to the numerator or the denominator of a fraction, and here we're going to assign it to the denominator 3. 14 times negative 3 equals negative y over 3 times negative 3 over 1. The negative 3 in the numerator cancels the negative 3 in the denominator, and we're left with y equals negative 42. So for this problem, we had both addition, subtraction, and multiplication and division in the problem.